Hello, so today we are going to do this problem, which is part of Leetcode context 304, a weekly contest. So the problem is longest cycle in a graph. And what the problem says is we have a directed graph of n nodes from 0 to n minus 1. And each node has at most one outgoing edge. So this is an important piece here. And the graph is represented with a zero indexed array of edges where there is a directed edge from the node I, which is the position, to node in the edges at position I value, right? And if there is no outgoing edges, we will mark for a node I, we will mark its value to be -1. Okay, so that's the setup, the input. And now what we want to return is the length of the longest cycle in a graph. And if there is no cycle, we want to return -1. So if we take a look here at this example, the only cycle and the longest one is this one here, which has a length of 3. So that's what we return here. If we take a look at the second example, there is no cycle, so we return -1. Now, one thing to know is that the length of the longest cycle in a graph, I believe it's NP for just general graph, but here we have something where that makes it easier to do, which is each node has at most one outgoing edge. Okay, so we know that each node won't have more than one outgoing edges, so we can't have, like, let's say 3 here with 2 edges like this going to 2 directions, right? So what this would mean, that each of them has at most one outgoing edges, means that each node will be a part of at most one cycle. You won't have a node that it is part of 2 cycles, right? So that makes this simpler to do. Yeah, so now with this laid out, let's see how we can solve it. Okay, so let's see how we can solve this. So the main idea, as I mentioned earlier, is that since we have each node has at most one outgoing edges, that means that each node basically can be in at most one cycle, right? So either one cycle or 0, right? And so what this would mean is that what we can do is just for each node try to find if that node is in a cycle, get the length of that cycle. And since we know each one is at most in one cycle, we can maintain a global set of visited nodes, and we can visit overall nodes just once. So what this would mean, okay, so let me clarify this a little bit more. So we will go through every node in our list of nodes. We can define what that is. And we can maintain a global set of visited nodes, right? Because let's say once we visit 3 to look at this cycle, to check this cycle here, right? And we are looking at 1, we shouldn't visit 3 again and look at the cycle, because we know we already found the cycle for 3. We won't find another one. It's at most in one cycle. So we only need to maintain one visited set. And here, only if the node is not in a visited set, that we do a DFS to find the cycle it's in, right? So let's delete this here. Okay. So now that we check that, and then we do a DFS that finds the cycle. So let's call it DFS here, and we'll pass the nodes. So what do we need to do to get the length of the cycle? So we need to maintain as well something like best, which just contains the initialized at -1, and this best here will just contain the longest cycle so far, right? Okay, so let's say we visit 1 first, right? Like this. So we visit 1 first. and do a DFS, right? So if we do a DFS, maybe we want to count the number of edges we traversed so far. So when we go from 1 to 3, we have the length is 1, right? And then we visit 3, and then we visit 2, now the length is 2. We visit 4, now the length is 3. We visit 3 again, now the length is 4, right? But now, how do we detect a cycle? Well, a cycle happens if we visit a node that we already visited, right? Like 3 here, but at the same time, we visited in the DFS call, in the same DFS call, right? Because maybe once we do the traversal for 1, we added 3 and visited, we start traversal from 3, 3 isn't visited. But that doesn't tell us that we have a cycle, right? It's only if we encountered, it's called the back edge, basically, which means we encounter a node in visited set, and that node was added in the call stack of our DFS. Basically, it was visited in the same function call of the DFS that started at 1. And so how do we do that? Well, we can simply maintain a call stack that adds all the nodes that we visit during the traversal for 1 node, okay? And so what we will do is we pass an empty list that represents that call stack, okay? And then here, we will also need to maintain the length, this 4 here. So from this 4, how can we tell the length of our cycle here? So we go from 0 to 3 to 2 to 4 and then back to 3. So this is what happens, right? Our cycle actually is just this, the overall length 4, right? Minus what was the value when we visited 3? And the value when we visited 3 is 1 because we just did one edge. And so we can just do 4 minus 1. And that will give us 0. That will give us, 3, which is the length of the cycle. Okay? So the question becomes, how do we find this one here? Well, in our call stack, each time we call DFS, we will add the node. So first we'll add 1, then we will add 3, then we'll add 2, then we'll add 4. So the indices are this, okay? So 1 actually is just the index in the call stack. That's the basically the length of the path so far, okay? And so we can just subtract that. So we can just subtract the index in which the value is equal to the one we are visiting, and then we will get the length of the cycle, right? It makes sense, right? Because since we want this, the length of this, and we have the length of the total, well, let's just take the length of this minus the length of this, right? It makes sense. Okay, and so what do we need? Since we start from 0 and then we do 1, 2 to calculate the length, we'll need to pass an initial value here of 0 for the length, right? So this is the initial setup. Now let's see how we can write our DFS to accomplish this. So for our DFS function, as we said, it will take the node, the length so far, and a call stack. Our call stack, or the nodes in our call stack, right? Okay. And of course, we know that the problem said that if a node doesn't have any outgoing edges, then its edges node would be equal to -1. So when we visit a neighbor and call DFS, the node, for a node that doesn't have any outgoing edges, node would be equal to -1. So we will need to handle that case. So we can say if node is equal to -1, we can just return. Okay. Now, we know we find a cycle if the node we are we know we may be in a cycle. So if the node is in the visited set, right? It may be either a new iteration for another node, like with the case of 0, or it's a cycle like with the case when we are going from 4 to 3. So we check if the node we are visiting is in visited, right? What should we do? Well, we want to check if it's in the call stack, because If it's not in the call stack, then it's this case, which is not the cycle case, right? And so to do that, well, we need to traverse the call stack. So we traverse our call stack, right? Let's actually do a range. So we traverse with the indices, range of the length of our call stack. And then what we do is we want to check if the value, remember our call stack is something like this. We want to check if each value in it is equal to the one we are visiting, which is the node. So if the call stack at position at position j is equal to the node, that means we found a cycle, right? So in the same DFS call, we found a node that we just that we visited before, right? So in this case, we want to keep track of that node. So let's just initialize I, that is initially to -1, and here set it to equal to j. So this is the index of the cycle thing. And now if I is equal to -1, that means we are in this case where we are going from 0 and we find a visited one. So in this case, well, we just need to stop our DFS because we know we won't find another cycle that we didn't find before by visiting from 1, right? So in this case, we could just return. Okay. Otherwise, if I wasn't equal to -1, which means we did find it in the call stack, we need to record if this is the best we found so far. So we need to get the max with best. Of course, this is a global variable. When we are implementing it in Python, we will handle that. And as we said, it's just the length so far, which what we did here with 4, minus the index in the call stack, which is I, right? So this would be the length so far minus I, what we said earlier. And we return in this case because we are done. We found the cycle. We won't find another cycle that started from the node because each node has at most in one cycle, right? So this is the case when we find an element that is invisited. But what if the element is, let's say, the first time we visit 3 or the time we visit 2? What should we do? Well, we should add it to the call stack, right? Because we are constructing our call stack, and we should add it to visited because we just visited it, right? So we do these two things here. So we want to add to visited the node, and we want to add it to also our call stack for this DFS call. So remember, visited is global and call stack is for each DFS call for a node that starts here, right? So here we append our node to the call stack of nodes. And then we call on the neighbor. We continue our DFS, right? And the neighbor is just 1 because each one has at most 1 outgoing edges. And so edges at node. And what do we pass? Well, since we are going one level deeper, let's say we are going from 3 to 2, here we had 1. Well, we should pass 2 because the length now is 2, right? This one and then this one, right? So we pass 2 here. So which means basically we increment the length so far by 1 each time, right? And then we need to pass the call stack that we updated here. So call stack, okay? And that's pretty much it. And then at the end here, we will return best. Okay, yeah. So the main idea, let's just reiterate, is to go through the nodes, maintain a global visited set, and then the main idea is this call stack here, which will allow us to know if there is a cycle. And then using that and using the index, we know what did we traverse before the cycle, and so we just take the total minus that, we get the length of the cycle. And then we check if it's the max or not. Yeah, so that's pretty much it. That's the main idea here. Now let's code it and make sure it passes test cases. Okay, so let's write down quickly what we just saw in the overview. So what we need first is the length of edges. We need our global visited set. We need our global value that tracks the max, best, longest cycle. And then we need to go through the nodes, which are just 0 to n minus 1, like this. And if the node is not visited yet, only in that case that we do DFS, and the length so far starts from 0, and then our call stack starts empty. And now we need to define our DFS function, and just push this here. That takes node and the length so far and our call stack. And then we need to check if the node is -1, which means it's from a node that didn't have any outgoing edges, so we need to return. We don't care about that case. And if the node is in self.visited, so this means it potentially there is a cycle here, or something that was visited before, like we said in the overview. Otherwise, we want to update. So it's not in visited, so we want to add it. And we want, so we know here we need to return and do a couple of checks here. And now here we want to add the node, and we want to add it to our call stack, right? And then we want to call DFS on the neighbor, which is each one has one outgoing edges, so one node, one neighbor. And so we do DFS of edges of node. Length so far we increase it by 1 because we are one level deeper. So we do +1, and then our call stack updated here, right? And so that's takes care of doing the next step. Now here we need to detect if there is a cycle, and if there is, calculate the length. And so what we do is we go through our call stack here. So we go through all the elements in our call stack. And we check if we want to check if the node exists in the call stack, which means there is a cycle, right? So this means found a cycle. And so we want to set the position of the cycle, right? The beginning of the cycle essentially here. This is J. Okay, and now, or J, whatever you want to call it here. And now once we find this, we can break here. And then we check if we want to initialize I here to some value, maybe -1, so that if we exit and we didn't find node in the call stack, which means there is no cycle. So equal to -1, this means no cycle detected. So in this case, what we want to do is just return, right? Node is already visited, no chance of detecting another cycle, so we just return. However, here that means we found a cycle, and so we want to get the best max of self.best, and so length. So let's call this cycle length. So our cycle length is just the length so far minus I. Okay, as we said, length so far is the total from the start, and then I is just the length before the start of the cycle, right? And so we just do cycle length. Okay, and that's pretty much it. So at the end we need to return the best cycle length we found so far, which means the largest cycle length we found so far. So we just return that here. Okay, so let's run this. Okay, let's submit. Okay, so that passes test cases. Yeah, so I think that's pretty much it for this problem. If you learned something, please like and subscribe, and see you on the next one. Bye.